1.7, the last topic in Unit 1 is all about absolute values, okay? So we're going to look at absolute value equations and inequalities. One of the reasons I leave this lesson to the very end is because we get to refresh solving equations and we get to refresh solving inequalities, just adding that absolute value piece into it. And so it makes it a whole lot smoother after we've already learned our equations and inequalities. So what we're going to start with today is just what is an absolute value? Someone tell me. What is the absolute value of 7?
7.
What's the absolute value of negative 13?
13.
When we're dealing with absolute values, we are talking about the distance from 0. So it's going to be a positive number every single time. So if I gave you this right here, and I said the absolute value of x is equal to 7, what number could I put in there for x?
7.
I could put in there for 7 because 7, absolute value of 7 is 7. What else could I put in there? Negative 7. So we're going to look at how we have to look at both the positive and the negative cases because both can give us the correct answer. So we're going to go ahead and we're going to look at steps to solve absolute value equations in 1.7 part 1, which is what we're looking at today. So the first step, okay, number 1, is to make sure the absolute value expression is isolated. So all that means is we need to make sure our absolute value equation is on one side and then everything else is on the other. So it needs to look like this, where we have our absolute value equals a number, not like this. So it's absolute value plus something else equals a number. We have to first get it so it's just absolute value equals number. Okay. Now, from there, we're going to take what is on the inside and set it equal to both the positive and the negative numbers from the other side of the equation. So just like with here, how x could be 7 or negative 7, what that would want us to do is say x equals 7 and x equals negative 7. So we take both cases, and that tells us what's happening. And then from there, we're just going to solve both equations. And then we write our answer as a solution set, which just is a way to write when you have solutions that are more than one solution to a problem. And the way we do that is we do x equals squiggly bracket, one solution and the other solution. And squiggly brackets, or braces as they're called, okay? How we write those? That is a squiggly bracket. If you are bad at writing those, you can kind of cheat it by making a normal bracket and then just adding like a little arrow in the middle. You can kind of cheat the squiggly bracket. Okay. I get some crazy looking squiggly brackets. Okay. I've gotten ones that look like this, ones that look like that, ones that look like that. Every now and then I get an S. I want us to work on getting them as close as possible to what they're supposed to look like, okay? If they're a little wonky, that's okay. We'll get better at them. I've had lots of practice at it. Some people pick up squiggly brackets super fast. Other people takes them forever to be able to draw one right. And that's okay. We'll figure it out. But when we write our answer as a solution set, we're going to do smallest number, biggest number. So we're going to go in numerical order. So smallest to biggest. Now, let's go ahead and look at some of these. So number 1. So our absolute value bars. So we have absolute value of x equals 2. So that's already isolated. So now what we have to do is take the inside, so x, and set it equal to the positive and the negative. So x is equal to 2 and x is equal to negative 2. Is there anything I need to do to solve those equations? No. So we're good to write our answer as x is equal to squiggly bracket, negative 2, comma, 2. Then we're going to look at question 2. So for question 2, we have the absolute value of m is equal to 14. So our absolute value is isolated. Then we do m is equal to positive and negative. Is there anything to solve those? So we are good to say m is equal to squiggly bracket, negative 14, comma, 14. Yes. Yeah, we go numerical order, so smallest number, then the biggest number. We will always put it so smallest, biggest. So for question 3. So here we have the absolute value of 5z is equal to 40. So we take the inside. What is the inside in this one? So we're going to do 5z is equal to positive 40. And we're going to divide both of them by 5. So we'll do, what is 40 divided by 5? So we get z equals 8. And then we can also here, negative 8. So z equals negative 8, comma 8. So for 4, what is our inside function for 4? So we're going to do negative 7a equals 28. And negative 7a equals negative 28. And how do what's the first step in both of those? What is 28 divided by negative 7? Yep, negative 4. And then what is negative 28 divided by negative 7? Positive 4. So a equals negative 4, comma 4. All right, for question 5, what is our inside, what is inside the absolute value of ours? So we're going to do d plus 1 is equal to 8, and d plus 1 is equal to negative 8. So we take what's inside and set it to both the positive and the negative. Now, how do I solve this? What do I do first? Well, it's already plus 1. So
minus 1.
What is 8 minus 1?
7.
Okay, then here, what is negative 8 minus 1? So to write the solution, we're going to do d equals squiggly bracket. What do we need to put first?
Negative 9.
Comma. There we go. For 6, what is our inside function?
W minus 3.
So we're going to do w minus 3 equals 4. And w minus 3 equals.
Negative 4.
And what do I do to solve those?
Plus 3.
What is 4 plus 3?
7.
Then do that same thing with the other equation. What is negative 4 plus 3? So we get w is equal to, squiggle bracket, negative 1, comma, 7. So it's essentially an equation with an extra step at the beginning. Okay, we have to take it and we have to split it into the 2, and then we just solve it just like any equation we've done in the past. So let's look at number 7. What is our inside function here?
4x plus 2.
So we will do 4x plus 2 equals 34,
That equals
and it equals negative 34.
minus 2.
And we will subtract 2 first. So what is positive 34 minus 2?
32.
So how do I solve 4x equals 32? X equals 8. Now, for the negative side, what do I do first?
Subtract 2.
What is negative 34 minus 2?
Negative 36.
Then I need 2. What is negative 36 divided by 4?
Ne-
Negative 9.
9. Yeah.
So we get x is equal to squiggle bracket, negative 9, comma, 8. All right, now we're going to look at question 8. What is our inside function? What is inside here? So we do negative 2x minus 5 equals 17. And negative 2x minus 5 equals negative 17. So I want y'all to solve both of those equations for me real quick. If you have questions, let me know and I will come help. Josh, what did you get for your answers?
Negative 11 and 6.
Exactly. Okay. So that's what we should get for both of our answers, negative 11 and positive 6. So all of these questions that we've just done, all of those already have step 1 done for us. The absolute value bars are already isolated. It's by itself on one side of the equation. Okay. So what happens if there is stuff outside of those absolute value bars? That's what we're going to look at next. So we're going to look at question 9. So in question 9, we have our absolute value of x plus 2 equals 12. So is my absolute value of x by itself? No. How do I get it by itself? Remove the 2, so minus 2 on both sides. So we get the absolute value of x is equal to, what is 12 minus 2? 10. From here, it's just like what we just did. So it should be x equals 10 and x equals,
Negative 2.
here we go. Yes. Negative 11 and positive 6. Negative 11 first, yep. Now, I will not count off if you write it flipped, okay, on the test. But I want us to really, really try to get better at making sure we put it in numerical order, because I might not care, but your next teacher might. So we're going to get really good at it now. And as the year goes on, I might get a little bit stricter about it, but I want us to get used to it. But try your best to put it first. Smallest number, biggest number. Okay? Now, number 10, what do I do here? Add 8. We get to isolate absolute value of y, so we need to add 8. So we get the absolute value of y is equal to, what is negative 5 plus 3? Yep, so we get y equals 3. And y equals? Negative 3. Do what?
You said 5 plus 3.
Oh, my bad. I do that occasionally. Because I know the answer. And so my brain's like, just spit it out first. Spit it out. All right, let's go ahead and look at the back once we are done with this one. Because we're going to look at some that get a little bit more busy. All right, so let's look at number 11. So for number 11, we have 6, absolute value of x is equal to 24. What is happening between 6 and the absolute value of x? What operation? It's multiplication. How do I undo multiplication? So I'm going to divide everything by. So we get the absolute value of x equals 4. So x equals 4 and x equals negative 4. So when we write our solution, we do so for question 12, what do I do in question 12? So I'm trying to isolate z plus 3.
Divide by negative 12 first.
Negative-
Negative 2 first.
What is negative 14 divided by negative 2? 7. So we get the absolute value of z plus 3 equals 7.
Now subtract.
No, before I do that, I got to set up both equations.
Oh yeah.
So z plus 3 equals 7,
And negative
and z plus 3 equals negative 7. Then we can solve it. How do I undo plus 3?
minus
So we get z equals, what is 7 minus 3?
4.
And do the same thing on the other side. What is negative 7 minus 3?
Negative
And to write our solution, we do z equals,
2. Negative 2.
comma, 4. For 13, we have our absolute value of 2x minus 4 divided by 6. So how do I get the absolute value by itself? Multiply both sides by 6. What is 3 times 6?
18.
So we get absolute value of 2x minus 4 equals 18. From here, what do I do?
Both of them.
So I do 2x minus 4 equals 18. And 2x minus 4 equals negative 18. So I want y'all to take a second and solve both of those for me.
A negative divided by a positive is a negative, right?
Emma, what did you get?
X equals negative 7.
Negative 7 and positive 11. And that is how we set those up and solve. Okay, now let's look at 14. What do I do first on 14?
Combine.
Let's talk about this. So if I gave you, don't write what I'm about to write. I'm just writing it. If I gave you negative 10x minus 3 equals negative 83, what would you do?
3.
Add 3. So why is this any different? It's not. It's not any different. They both have the negative 10 in front. In this one, we're just solving for x, whereas in this one, we're trying to solve for the whole absolute value. There's no difference, okay? We do the same order we would do if it was just a simple equation. So what do I need to do first? Add 3.
But the negative 10 doesn't have like an operation.
It's being multiplied.
Okay.
So we get negative 10 times h plus 5 is equal to, what is negative 83 plus 3? Then how do I undo multiplication? So absolute value is unique over parentheses because I don't distribute here. I can't distribute there. Okay, I can't distribute into the absolute value. So that is why it is so different. So we get h, absolute value of h plus 5 is equal to, what is a negative 80 divided by negative 10? And then I want y'all to solve it from here. Yes.
Okay, so we take negative 8. Okay, and we go back 5. So negative 9, negative 10, negative 11, negative 13.
Negative 13. I have 13.
I wouldn't know that off the top of my head. How'd you, that's why you count it out. Like you
And
literally
8, not negative 8 minus 5. Or is that, is that 3?
So think about it like that.
That's 3.
Right? Negative 8. And then you minus 5. Make sure you show that. So you go minus 9.
That's negative 13.
Take it out.
Then how'd you get 3? 3 is from 8 minus 5.
That's what you're doing. You're just literally
So
backing
how'd you
it up
get
or
13?
going.
Negative 13. And 3. You did 8 minus 5 and you did 8 plus 5.
That's all.
I didn't do that. I just did 1.
All right. So our answers for this one should be what?
Negative 13 and 3.
Negative 13 and 3. So now let's go ahead and look at 16. Okay, for question 16, what do I need to do first? Add 24. So we get 3 halves times the absolute value of 4r minus 4 is equal to 3. Now, how do I get rid of a fraction? I can multiply by 2. I can do it in steps. So you can either multiply by the reciprocal or you could do it in steps. So multiply both sides by 2. What is 3 times 2? 6. Then what would you need to do if you did it in steps? You would need to divide by 3. So divide both sides by 3. What is 6 divided by 3? So you get the absolute value of 4r minus 4 equals 2. Now you could also do it by just multiplying by the reciprocal first. And so that still gives you the same thing. That would still give you 6 over 3, which is just 2. Either way works. Whichever way makes the most sense to you is good with me. Okay, now, set that up. So 4r minus 4 equals 2. And 4r minus 4 equals negative 2. So I'm going to let y'all have a second to solve those. Actually, I'm going to do them with you because I want us to talk about it. So for the first one, we're going to add add 4, right? And we get 4r equals 6. What do I do from there? Divide by 4. So we get r equals 6 over 4. Do I want our answers as fractions or decimals? Fractions, okay? So what we are going to do is we have to simplify it if we can. Can I simplify 6 over 4?
Yes.
What can go into both 6 and 4? 2. So 6 divided by 2 is? 4 divided by 2 is? 2. So that's our first answer. And we do the same thing for the second answer. So add 4 on both sides. What is negative 2 plus 4? Divide by 4. We get r is equal to 2/4. Can I simplify 2/4? So our solution is r is equal to, which one's smaller, 3/2 or 1/2? So 1/2, comma, 3/2. All right. Now we're going to talk about our special cases. Okay, so our special cases happen in questions like number 17. Okay, so number 17, I have absolute value of x is equal to negative 6. Is there, what is if I said the absolute value of 6 equals negative 6, can I do that? Will my absolute value ever be negative?
No.
No. So what do you think that means for this problem?
You can't solve it.
You can't solve it, so that means there is.
So
Then-
is this gonna be like 0 or that?
You can also write it as the empty set. You can do x equals the empty set. All right. And that empty set just means there's nothing in the set. It would be like having the little bracket thing, but not putting anything in there. That's what that means. So for 18, we have negative 3 times the absolute value of 2x plus 1 equals 21. What can I do from here?
5/3.
Yep. Divide both sides by negative 3. And we get the absolute value of 2x plus 1 equals, what is 21 divided by negative 3? Can I do that?
No.
No. If your absolute value equals a negative, it is no solution, or the empty set. Okay, so when an absolute value equals a negative, it doesn't work. Okay, we just have to be careful because sometimes we can have problems like this one here. So if I have negative 2 times the absolute value of x equals negative 5. Right now I have something equals a negative, right? But am I good to write no solution here? What do I need to do?
Divide by the negative.
And a negative make a, so we get the absolute value of x is equal to 5 over 2. Or x is equal to the set of negative 5/2 and positive 5/2. So even though this one starts as equal to a negative, it changes and still has a solution. So we just have to watch for those things and not just automatically go, oh, equals a negative, equals no solution. Okay, I'm done. Okay. Make sure that you have it isolated first, then do no solution. So down here at the explain section, we're going to actually write this out. Okay, so what we're going to do is we're going to say absolute value functions. Cannot equal a negative. So when an absolute value equation equals a negative, there is no solution. Any questions about that? All right. So on Monday, we are going to pick up with 1.7 part 2, okay? And we're going to do absolute value inequalities, okay? Then on Tuesday and Wednesday, we are going to review and review. And Thursday will be part 1 of our test. And Friday will be part 2 of our test, okay? So part 1 of our test will be no calculator, okay? Everything can be done without a calculator on both parts of our test. But the more challenging numbers to deal with, those will be on part 2 of the test, where you can use a calculator, like fractions, things like that. So make sure you are prepared for that next week, okay? We are almost done with Unit 1. Thank goodness, right? Yes.